Good afternoon, all you learners. I hope you are ready for electrodynamics. Let us get going. This is the last section of the physics for your matric paper, so let us get going. I wonder if you can remember from last year, we had all those hundreds of rules. Well, not quite hundreds, but we had about 5 different rules. I'm just going to recap them, but at the same time, matrics, I want to tell you that don't spend too much time studying those rules. You will see when we do question papers now, there are very few questions regarding that. And the amount of time you're going to spend to study that almost doesn't warrant the marks. I know I shouldn't be saying this, and I know if people are listening, they're going to say, but you must learn everything. But sometimes we have to look at how much marks something is worth. It is better for you to be able to do the calculations in electricity and in electrodynamics. It's better for you to be able to identify the difference between motors and generators and things like that. Obviously, if you understand the rules, then it's great. But if you don't understand it, then it's better just to sort of give it a skip. I know the girls really struggle with it. You're going to see just now when I use my hands, I never know what's happening because we do find it more difficult. Right, let's quickly have a look at electrodynamics. Right, when we have current in a current carrying conductor in a magnetic field, we will see that the conductor experiences a force, right? And to determine that direction, we make use of Fleming's left-hand rule. Now, this is quite important for you to remember 2 things. Number 1, the current carrying conductor will experience a force. And secondly, the direction is given by Fleming's left-hand rule. Okay. Now, that we must remember, because just now we're going to get a right-hand rule as well. Right. Fields in opposite direction, they cancel out and become weakened because of a downward force. Now, let us quickly have a look at a few of the other rules. Right, this one was just the normal one where we had the right-hand rule, where if you take a current carrying conductor and you put it in your hand like you have in this way, your thumb points in the direction of the current and then your fingers will point in the direction of the magnetic field. Can you see that the direction of the magnetic field is at 90 degrees to the current? There's the current and there's the magnetic field. Look at the direction of the magnetic field. It's in the direction that the fingers pointed. Okay? Right. Now we get, as we carry on, we have the magnetic effect as well. Excuse me, it's quite important for you to remember. Right. A magnetic field, we already know, is generated around a conductor in which we find an electric current. Now, if you have a look at this specific picture, okay, can you see that is what is happening here? The current is actually coming towards you. And how do I know that? If you have a look at my hands, you will see that this is my current carrying conductor. Now, I am going to point my thumb to me, because that's the direction that the current's going. And can you see that the magnetic field now follows my fingers? Eh? Right. And if you have a look at the way that it is on the data slide, you can see that is the direction of the electric current. Now have a look at this one. The one on the opposite side of the page, your current is going in the opposite direction, which means what would have happened there? My thumb would have pointed to you, and my fingers would have then gone clockwise around. And that is the direction of my magnetic field. It's something I find quite hard to remember, is that the dot indicates it's coming to me, while the cross indicates it's going away from you. Right, so that is how you know which direction it is moving. And then from there, you can determine the direction of the electric current, of course. Right, now, what we work with more in matric is the electric motor and the generator. Okay, and what you need to know is that there's a big difference between them. You need to know that a generator generates electricity. Generator generates electricity, okay? And what does generate electricity means? It means it produces electricity, okay? So it takes mechanical energy and converts it into electrical energy. We're going to speak about that a little bit later. Now I'm going to speak about the motor because I've got the motor on the screen at the moment. A motor takes electrical energy and converts it into kinetic energy. Okay. Now the first thing you must remember, when you get your paper and they give you a picture, the first thing you have to look at is there a power supply? And in this case, there is a power supply, positive and negative. Okay. That immediately indicates to me that I am busy with a motor. Okay. And what is the conversion of a motor? Electrical energy to kinetic energy, or electrical energy to mechanical energy. Right, now in this particular case, they say to us, indicate the direction of rotation with an arrow. Show the application of the rule used and decide which way the coil will turn. Now this is the type of question that I'm referring to. It's going to take you quite a lot because you're going to have learned the left-hand rule, the right-hand rule, all of them, okay? And if you can remember, in this particular case, we're going to use the left-hand rule, okay? And we are going to use, I always teach my learners, FBI. F is the force, B is the direction of the magnetic field, and I is the direction of the current. And these two, can you see the direction of the magnetic field and the current? They are at 90 degrees to each other. Okay. The other thing I teach them is that I know when I say N for knuckle, you're going to tell me, no, Mrs. Van, and even if you don't spell knuckle with the N, you spell it with a K-N. But we're going to forget that. I always remember knuckle, knuckle, north. Finger, south. Okay. So that is the basic thing you are going to do. Right, so what is going to happen in this case? Look on my left-hand side. Right, can you see that on that left-hand side over there? The current is going away from me. Right, the current is going away from me. Let's just get this right because I'm now getting it wrong already. Right, remember this is current. So the current is going away from me, right? This is my north pole, and my knuckle must point to where the north is. So my knuckle and south, okay? This finger is my magnetic field. It points from north to south. This is the direction of the current. The current's moving away from me, okay? Right, so what direction is my thrust? My thrust is in the direction of my thumb, okay? Can you see that? There we go. There's the direction of my thrust. Okay. So in other words, my rotation is going to be anti-clockwise. Look what happens on the other side now. Look what happens on the other side now. Can you see this green arrow that the current is coming to me? So remember FBI. FBI. Hey? Okay? I is current. So the current is coming to me. My knuckle is in the north, south, which means my thrust is going to be in the direction that my thumb is. So my thrust is going to go up. So this coil is going to turn that way. Okay, have you got that? Okay. Just remember once again, just in case you've forgotten, the direction of conventional current is from positive to negative. So the first thing I actually did here is I would have filled in my arrows. And how do I know that? Because this is my positive and this is my negative. Right. So I had my arrows, then I also had my magnetic field. And from there I worked out my thrust. Okay? I think I should go over that again. See if you can follow me. Right, so let's go back to the previous slide when we had a blank slide. What was the first thing I did? I looked at my current, positive to negative, which means my current is moving away from me and towards me. Okay? Now what do? My current's moving away from me, so the first thing I do is I make sure that the current is moving away from me. Okay? I could have done it that way too, but you'll see now. So the current's moving away from me. The next thing that I also know is where's the north pole. And remember, the north pole is where my knuckle is, okay? So it goes north to south, okay? Which means my thrust will be down. On the other side, what happens? My current is coming to me. The current is coming to me. North to south, my thrust is up. Okay, got that?